I think this is actually going to be a pretty good follow-up to Lou's presentation. But yeah, I'm Jameson Lopp, Chief Technology Officer at CASA, and at CASA we are primarily concerned with enabling users to be self-sovereign, and of course there's many different aspects to that. But what I'm going to talk about today is kind of related to self-sovereignty, but it's a much higher level type of talk. So we have to begin, of course, at the beginning. What is a blockchain? It's a chain of blocks. I'm a technology guy. When people say blockchain, I hear database. So instead of this overarching theme where people are just saying blockchain this, blockchain that, I think that that is glossing over a lot of the details that are very important to these systems. So when you create a blockchain, all you're doing is creating a linked list of data, a new type of data structure, and it's cryptographically linked together, so you get tamper evidence from that. That's all you really get in addition to ordering. You can say this thing happened after this thing, but other than that, most of the other stuff that people think of when they say blockchain is not actually guaranteed from the blockchain itself. What is a blockchain not? It's not a consensus protocol. It's not a network of nodes. It is certainly not an arbiter of arbitrary truth. It may be able to tell you certain things depending on what the consensus protocol actually does. It's not even a timestamping service. You have to have other parts of a protocol in order to ensure that the consensus around when these blocks were timestamped is in a certain range. It's also certainly not an immutable or finalized record. The blockchain itself only gives you tamper evidence. You need other things such as a proof of work or proof of stake or some sort of other consensus mechanism that makes it very expensive for someone to rewrite the blockchain and make it immutable. And of course, a blockchain is certainly not this diverse ecosystem of participants that come together to build it, use it, and evolve it. So my main point is a blockchain is not magic. You can't just sprinkle blockchain on a problem and come up with a revolutionary solution. You have to carefully consider all of the different aspects of what is making that blockchain function and how people are interacting with it. So to get to the real meat of this talk about bureaucracy, what is bureaucracy? It is basically the creation and enforcement of policies. And bureaucracy is how human civilization has gotten to where we are right now. We have created these hierarchical command and control systems over the past several millennia to help us organize ourselves, to help us specialize, so that no longer do any of you need to actually worry about growing your food and the entire process of sustaining yourself. Instead, you can delegate that off to other people who are specialized and probably work for companies and other hierarchies to be very, very efficient and productive at doing one or two things. So the result of this, though, is that you have a system where there is a lot of power concentration at the top, and this power is basically being used to coordinate the other layers of people and things that are actually getting stuff done throughout the company or public sector, private sector, really any organization of people. This is very efficient, but of course it has some trade-offs. And I don't think that as a society we've really thought about these trade-offs very much until recently. So bureaucracy and governance in the real world in most organizations, they're very similar. Usually the governance is what initially creates a set of bureaucratic mechanisms, and then it's self-reinforcing over a period of time. The governance and the bureaucracy are basically a closed loop, and usually policies are used to continue to extend and update the policies. On a distributed crypto network where we've got a protocol and a bunch of people that are running software and nodes around the world, it's basically the same thing. And we'll talk about a little of how this actually works at a technical level in a second. But because the protocols are essentially enforcing rules that you have agreed to run, you are then able to enforce these rules 24/7, 365, and only you really get to say how those rules might get changed. So governance is really more about who can change the rules, right? There's many different types of governance. I've got a few of the major ones up here. there, everything from like a dictatorship to a democracy to federations, republics, and of course there's various hybrids of these things. I would argue to you that a public permissionless crypto network is actually more on the anarchy side. And one of the reasons that you get into a lot of contentious debates around governance of these public permissionless protocols is because people are trying to shoehorn them into other governance models that they're used to in the real world. So when we're talking about deciding changes, humans like to have what you could call a decision function. And this is essentially the way that we are voting to make the decision. Because we have high time preference. We don't want to wait around for the rest of our lives trying to come to perfect consensus about how to change a system, because you're probably never going to be able to get everybody to agree on any one given thing. So instead, we come up with these different types of governance, these different decision functions that take inputs and give us one clear, decisive output. But of course, there's a lot of pros and cons to this, the pros generally being that you can make the decisions faster, the cons being that if you start talking about fairness, there's probably no system of voting out there that everyone is going to agree is fair. Have an example up here with Ethereum coin voting that happened a couple of years ago around a forking situation. And we saw a number of things happen in there, one of which you can see only about 10% of the total Ether supply was actually used to vote. This is an issue of voter apathy that is common in all types of voting. And then when you actually dig into the votes that did occur, you see that 25% of them belonged to one voter. And of course, this is just due to a concentration of wealth in that system at the time. So you've got voting. That is how most governance systems work. But how do you do it in a system of anarchy, where there are rules, but there are no rulers? The closest thing that you can do is signal. Put up some kind of flag, some kind of flare that you shoot off that says, hey, I'm going to go this way, and if you want to follow me, you can, and if you don't want to, nobody's forcing you. So there's also kind of a moral issue at play here where you could make arguments that all types of voting are in fact a form of coercion, and whether or not you believe that the pros and the cons weigh off of against each other, that you would agree with that. That's a debate that you can have for quite a long time, but I think the main point I'm trying to make is that while you see people say that there are types of voting in these systems, even the voting that does happen is actually generally just a different type of signaling. And when we're talking about different models of governance that people try to apply, I've seen various models get applied, especially like during Bitcoin scaling debates. We see some people point at certain organizations and say, oh, this developer organization is clearly the center of power because they get to make the decisions, and then everyone else has to follow along. Or other people might say, oh, look at the miners. The miners are the ones that create the blocks, and therefore, whatever they decide should go into a block is essentially going to force everyone else to have to go along with that. And of course, these protocols are extremely complicated. There's a lot of game theory involved, and you can go around and around in circles for years, as many people have done, arguing about how the balance of power actually works in these systems. And I think that's generally a fruitless thing to try to talk about. Instead, what I think is worth trying to talk about is how self-governance works. And hopefully you can read this, but if not, what we've got here is a very low-level model of how data propagates around these networks. Bitcoin, Ethereum, what have you, is that if you're running a node on this network, you're connected to some other nodes, and they come up to you and they say, hey, I've got this piece of data. It's a block, it's a transaction, it's some sort of message as a part of the protocol. And they say, hey, do you want this data? You look at it, you say, oh yeah, that looks valid. It conforms to the rules that I agree with. You accept it, and then you turn around and you talk to all the nodes you're connected to, and you say, hey, I have this piece of data. Would you like to have it? And they do the same thing. And this is called a gossip protocol. It allows you to flood the network very quickly with any message, assuming, of course, that the nodes accept it and relay it. On the right, we have a situation where someone tries to pass a message that the other node deems invalid. And the interesting thing here is that they don't really have to take any action. If they don't want to accept it, they just ignore it, they drop it. In some cases, they may disconnect from that client because they think they're being malicious, but it is really the power of apathy or the power of inaction that I believe gives power to this form of governance. And the result is you have this huge collection of individual actors. It's a huge mesh network that is composed of many tiny other mesh networks, and they're all working organically in concert with each other to propagate information and come to a consensus about what they collectively agree upon. This is what I consider to be inverted bureaucracy. This is an example of how a block propagates through the Bitcoin network. It's actually slowed down 500%. This happens in about 2 seconds. And as you can see, these nodes, they're talking to each other. They're saying, hey, do you want this block? They accept it, they validate it, they relay it. And within about 2 seconds, we can come to a global consensus about making updates to the current state of a ledger. When I look at this, it's really a thing of beauty. I actually see it in the way that Ralph Merkle referred to Bitcoin as a new form of life. This is some sort of new organism that we're still trying to figure out all of its complexities and intricacies. And so, like I said, some people try to talk about balance of power a lot. Michael Goldstein famously put this Twitter post up a year or so ago where he's like, you know, in Bitcoin, everybody's watching each other and they've got a gun on each other, and if anybody tries anything funny, then they're going to take them out. They're going to, you know, basically kick them off of their network. And while that's a graphic way of portraying it, I think that instead you can think of it from more of a defensive standpoint of like, you know, we're connected to each other with ropes and we've got a scissor and we'll cut you off if something goes wrong. But the point being that I'm going to pose to you that in these networks, the power of the veto is as strong, if not stronger, than the power of the majority to overrule other people. And that when we talk about fairness and equity, those are very controversial terms in and of themselves. I think that the most fair system that you can get is one in which any participant can veto anything that they want. And essentially, this gives you the ability to create a system where you may not be optimizing for that which is the best for the majority. I believe that it instead creates a system where you're optimizing for that which is least harmful for the general user base. So decentralization is a word that gets thrown around a lot, and this is one of the things that I try to warn people about when we're looking at a blockchain, is that there's so many different facets that compose these complex systems that if any one of them is particularly centralized or has too much power in one part of it, that can actually become a critical flaw. So you have to be very vigilant and careful when you're evaluating any of these systems to make sure that all of the appropriate aspects of them have distributed the power as much as possible. A good example is that there's a number of tokens that are built on top of Bitcoin and Ethereum and whatever, where the tokens themselves have code in their contracts that allow a single person or a single entity to censor and to make arbitrary changes to the token holders within that system. So you have to ask yourself, if you're using this awesome, robust, censorship-resistant network, but then you've created a trapdoor in the protocol you built on top of it, do you really still retain all of the value of that network? And so what am I really getting at with all of this? You hear a lot of people talking about technical scaling solutions and all of the performance problems that we have with blockchains, because blockchains are probably the least efficient database that has ever been created. But I think that a lot of people are overlooking the issue of social scalability. So what is social scalability? Well, Alfred Whitehead said, civilization develops by increasing the number of important operations that we can perform without thinking about them. And if you think back to bureaucracy and how civilization has evolved with these command and control hierarchies, that is the great question, the trade-off of the efficiency versus the resulting systemic risk that we create by centralizing power in the hands of a few. And so I believe that these blockchain-based platforms can enable us to create systems that are socially scalable, which means that the cost of participating in the network and staying in the network is much lower. And I don't mean the cost from a technical standpoint, but rather from a cognitive standpoint. If you are aware of the idea of Dunbar's number, he's basically talking about human brain can only really keep about 100 to 150 other relationships in play at any given time before we kind of get cognitive overload. And when you're in a system that the other participants in the system have sufficient power that they can pull the rug out from under you, change the rules, and really change the game, then you have to be worrying about all of these other participants and the power and how they might use it. But if we can build robust platforms where the power is so decentralized that you can create a much more resilient and trustworthy system, then people can interact with each other and use that system with very little cognitive overhead. And the main point that I would try to get at here is that with blockchain-based platforms, we can create truly free markets that are socially scalable, where we can achieve this by creating a system where you don't have to worry about all of the power dynamics and the games that are being played behind the scenes, but rather you just worry about what you yourself agree with. And we essentially do that by inverting and automating bureaucracy to create these new type of organisms. And this is a very complex topic. I hope I've been able to distill some of it in the short 20 minutes here, but I'm very happy to talk about these issues and many other technical issues. Just catch me after. Thanks.
Thank you very much, Jameson. Some interesting food for thought here. Any questions from the audience? Yes, please.
Yes, hi. Can you please explain to us how you're using these incentive structures and operational structures for CASA, which you meant self-sovereignty, which I'm assuming is
Yeah,
exactly?
so actually, with CASA, we are not trying to change any of the existing structures. At CASA, our thesis is that the structures that are in the top public permissionless networks are already very well formed, and we should not try to screw around with them. So instead, what we try to do is understand how those structures work and create software and hardware that allows our users to make use of them. And by that, I mean, from a more technical level, allowing them to create and run and maintain fully validating nodes that are essentially running this bureaucracy in their own home in a way that doesn't require them to have a lot of technical overhead to understand how to run and maintain the software. And then from a privacy and security standpoint, to create additional layers of abstraction on top of these systems so that it is more of a plug and play or mobile app type of experience rather than the current experience that results in a lot of people having to use more like command line tools or using tools that have been built mainly by developers for other nerds. So really, we don't think that like the underlying architecture of the systems need to be changed. We just are trying to help people better understand how they work so that they can then understand the way that they can best operate inside of them.
Other questions, please? Yes.
Hi, I'm Robin, I'm in payments. What I really struggle with is which parts you can decentralize and which parts you can't, and where, because it's so integrated, and so how do you determine which parts you can take out and implement blockchain smart contracts, decentralize, and then still let it live within the traditional ecosystem?
Yes, and one thing I didn't really talk about is that, of course, there are a million different applications of blockchain technology, and we're already seeing a number of enterprises come together, and some of these blockchains will not fit into an anarchistic model. They will fit into a federated model. A good example of that would be like a number of systems, Liquid sidechain, for example, which is actually pegged out of Bitcoin, but once you're into Liquid, you're operating in this new federated model, and you get trade-offs, like you get faster speed, you get new privacy functionality that doesn't exist in Bitcoin, but the trade-offs are that you no longer have the same level of trustlessness. But from an even more meta standpoint, trying to control these systems may be a fool's errand. It seems to be more an issue of how is the system initially born, because once the system is initialized and created, it is very difficult to make it more decentralized. It's usually very easy to make aspects of it more centralized. So I think that this is why you see, at least in Bitcoin, it seems to be a constant battle, right? We're constantly fighting with each other about changes to the system because some people are extremely concerned that if we go even an inch in the wrong direction, we're never going to be able to go back the other way. So it's very easy to lose your power in any system. It's very easy to become frustrated because there's no decision-making function, and things can take a lot longer to implement changes. So it's very easy for you to cede some of your power to another entity, and I would argue that that actually is what happened with SegWit2x and Bitcoin Cash, is that certain people got frustrated at the lack of change, and so they came together and said, oh, we have the power and we can go make changes, and now they're going forward on their own path, and it's very fascinating to see the results of that. In fact, in a few hours, like with the Bitcoin Cash latest fork, I mean, it's just a fascinating social experiment, and none of us really know where it's all headed, but I think the best that we can really do is participate and do what we can to try to build these systems.
Yes?
Jameson, Ian Grigg. The blockchain presents a very antagonistic model of human behavior, which creates a lot of competition, but also a lot of adverse effects. I would suggest that if we can improve the level of interaction, dare I say it, introduce more trust, we can compete for more benefit. So firstly, do you agree with that? And secondly, how do we increase the ability to do trusted competitive trade, where everybody benefits?
Well, so I think one of the fundamental issues, at least within any of the public permissionless blockchains, is an issue that's fundamental to almost everything, which is limited resources. And so a lot of people are fighting over limited resources that they have to put into supporting these public networks. But in general, this is a very free market mechanism. I don't think that many aspects of it can be controlled, and that more competition in general is only going to make it more robust. Going back to one of the earlier talks with the cryptographer, he said, even within these systems, they're not fully trustless. Like, you're at the very low level having to trust the cryptographers. Or, most of the people here are probably not looking at any of the source code for the actual node implementations or your wallet implementation or whatever. It really is, I think, creating a hierarchy of trust in some ways. And there may not be any way to get around that just due to the layers of complexity that is involved in everything. But how do we incentivize more competition? The best thing that I can do is kind of what I'm doing here today, to try to explain to people what your options are. Why should you be interested in using a system like this that is arguably harder to deal with because you have to understand it better in order to fully make use of the security and the privacy and the other functionalities. I think end game to all of it is just building more layers of abstraction so that people don't have to be worrying about this. I do believe that, like most protocols, over the period of years and decades, the protocol will eventually ossify, and it will be ridiculous for us to even be having discussions about making changes to the protocol. And I would give you historical pointers around looking at how the internet protocols like TCP/IP or SMTP or even HTTP, no one makes changes to these protocols anymore. And it's not because the protocols are perfect and that they can't be improved. It's because the trouble that it would take to make changes to them is not worth it trying to go out and get consensus. Rather, it is much easier to extend the protocols, build on top of them, build more and more layers of abstraction. So I think that that is going to be the natural evolution that will eventually get mainstream or majority inclusion, is when we're able to make it just dead simple for people to use these protocols. The people that are using Facebook and social media and websites today, almost none of them know TCP/IP or any of the stuff that's going on under the hood. And so I think that is what we should aspire to be like with these blockchain systems, that hopefully someday blockchain, it won't be a buzzword, it'll just be boring old technology. Yeah, there's a blockchain under that, there's a blockchain under everything that's important these days. No point talking about it.
Fantastic, some great thoughts here. Please join me in thanking Jameson.